Impressive.
Pakistanis are actually using gravity to install gears.
Only Pakistanis could come up with such an idea.
Take an ultra-thick iron disc, drill a hole in the center.
Drill all the way through, then use a large drill bit to widen it. Next, mount it onto the lathe and lock it in place.
Adjust the cutting tool.
Start the machine. The cutting tool slowly descends. It fits right into the hole, and it gradually starts cutting downward.
After cutting one round,
it continues expanding the hole further.
Once done, the original surface is removed. The smoothing tool slowly advances inward.
The machining goes on gradually. Once the round surface is smooth, they adjust the cutting angle and continue.
Looks like the iron bar still isn't perfectly round. There's a bit that still needs trimming. Then they cut down from the top.
Even with deep cuts, the iron shavings stay intact, oddly satisfying.
They can't machine the very bottom, so they loosen the fixture.
Stick an iron bar and a chain through the center. That way, they can lower the iron piece, then flip it over. Mount it back on the lathe.
Continue machining.
Since the cutting tool isn't long enough,
there's still a small hole at the bottom. They keep using the same method to slowly machine it. After some time trimming,
a shiny, large iron disc is finally completed. 2 ears are welded onto the round face. They attach chains and bolts to the ears.
After lifting the iron bar, they clean the round surface underneath.
It doesn't look safe at all. Feels like it could fall any second.
But Pakistanis are bold. They slowly lift it onto the gear hopper, probably not high enough. So they put another gear underneath to raise it.
Gear machining is precise work. First step, find the center. Fix a dial indicator on the lathe mount. Start the machine slowly to find the center. You can see the dial indicator constantly jumping.
Bring in a big sledgehammer.
Bang, 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 hammer it upward.
Feels like the force isn't enough, so they push up using a large axle rod.
But they can't use too much force either. Once it's about right, place a gear on top of the iron disc.
Then add a smaller iron disc.
Tightly fasten it with a large nut. Next, measure the flatness again. This technique is really impressive. The dial indicator doesn't even move,
but it still looks pretty hollow underneath.
If not done right, it could fall off.
They use several bolts as supports underneath, like spider legs.
After setting everything up, they still need to test the flatness. Get a big wrench.
Add an extension rod.
Tighten it with force. One person isn't quite strong enough.
2 people is just about right. The reason for locking it so tight. Even a tiny shift during gear cutting is unacceptable.
Tightening the fixture improves gear accuracy. Next, they adjust the cutter angle.
Looks like the angle is about 20 degrees.
Turn the handle and slowly move the tool toward the blank.
Rotate the tool slowly. After one full turn,
you can see clear gear lines on the blank. The machinist carefully counts the gear teeth. A total of 70 teeth.
Once confirmed, the cutting process can begin.
Gear hobbing is a commonly used method for making helical gears.
It relies on the relative motion between hole and blank to cut out the gear teeth. These gears have the advantages of smooth transmission,
high load capacity, and reduced noise. They're typically used in heavy machinery. After finishing, the gear is placed on a gantry mill. This setup isn't stable enough for clamping,
so they simply weld it in place.
They need to cut a keyway inside the inner ring, a groove. Next step is heat treatment of the gear. The machine gear is heated to 800 degrees Celsius, up to 900 degrees Celsius. Heat treatment improves hardness and strength,
and increases wear resistance.
Heat treatment means taking the red-hot gear
and plunging it into a water tank for rapid cooling.
After that,
the machinist checks the gear's hardness. Then it's installed onto the shaft.
The master hits it directly with a big hammer. He hammered it exactly 81 times.
Still felt like it wasn't enough force, so they switched to using a big axle rod. That sped things up, but the final bit
was still tricky. They applied some machine oil, then lifted it up.
Align it vertically with an anvil on the ground.
Raise it to the highest point. Then hit the switch. The gear shaft drops straight onto the anvil. This method uses gravity itself to mount the gear. Only Pakistanis could come up with something like this. Once the bearing is in place, the reduction gear is complete. So, folks, what do you think of Pakistani engineering?